Hello everyone, welcome back to Aero Hub and welcome to the series of lectures in Gate Solution. In this lecture, we'll discuss about previous year questions of rocketry and space mechanics. And both this question was asked in Gate 2008. Which of the following quantities remain constant for a satellite in an elliptical orbit around the Earth? Option A, kinetic energy. Option B, product of speed and radial distance from center of the Earth. Option C, rate of area swept by radial vector from the center of the orbit. Option D, rate of area swept by radial vector from the center of the Earth. Okay, and I will draw one diagram. This is the planet, and here is the orbit. Okay, this is your orbit. Okay, this is the elliptical orbit. Okay, my diagrams are not so nice, and this is the Earth, planet Earth, and this distance I can consider as the apogee. Okay, RA, and this distance as perigee. Okay, the shortest distance. Okay, just imagine. Okay, and this is Earth and this is the orbit, and just imagine this is your satellite. Okay, and you can see that this satellite will be operating in this orbit, and whenever the satellite is near the at the apogee, the satellite will be having less speed. Okay, because the distance from the planet to the satellite is very high. That means the attractive force, the gravitational force of attraction will be very less. That means the speed will be very less when the satellite is at the apogee. Okay, similarly, when the satellite when the satellite is at perigee, at this point, the distance between the satellite and the earth is very small, and the satellite will be operating at a high velocity. Okay, this concept we are using in the next problem also. That means the value of velocity is varying throughout the orbit. Therefore, option A as well as option B will be negligible. Okay, then for option C, the rate of area swept by radial vector from the center of the earth, center of the orbit. Okay, and option D is rate of area swept by the radial vector from the center of the earth. Okay, so according to Kepler's second law, the rate of area swept by the radial vector from the center of earth is constant. Therefore, option D is the right answer. Okay, you have to understand this basic thing. That is, when the satellite is at the apogee, it will be operating at a very less speed. When the satellite is operating at perigee, it is operating at a very high speed, and there will be change in the kinetic energy. Kinetic energy is half mass into v square. Okay, so this is the correct answer, option D. Now we'll go to the next problem. A planet is observed to be at its slowest speed when it's at a distance r1. Okay, that is, this r1 is nothing but the apogee. Okay, this is nothing but apogee distance ra from the sun, and it is fastest when it is at a distance r2. This will be r2 will be perigee, rp. The eccentricity e of the planet orbit is given by, okay, so e is equal to r1 by r2. Option B, e is equal to r1 minus r2 by r1 plus r2, and option C, e is equal to r2 by r1. Option D, e is equal to r1 plus r2 divided by r1 minus r2. Okay, so r1 is the apogee, so I can write r1 is equal to a into 1 plus e, and r2 is equal to a into 1 minus e. Okay, these are the two equations. Okay, these are the fundamental equations. I'm not deriving this equation. I am now dividing r1 by r2. r1 divided by r2 is equal to a into 1 plus e divided by A into 1 minus E. Okay, so I can cancel out A. So I can write R1 into 1 minus E is equal to R2 into 1 plus E. Okay, so finally I can get R1 minus R2 is equal to E into R2 plus R1. Okay, so I can reduce this as E is equal to R1 minus R2 divided by R1 plus R2. Okay, this is the correct answer, and the answer is option B. Okay, so we discussed about Kepler's second law, and also we discussed about the speed of satellite at Apogee and Perigee. Okay, so that's all about this lecture. Thank you for listening. Take care.